There are 4 questions with solutions. 2 angle measurations. 1 algebraic equation and 1 trigonometric equation. Algebraic substitution method. Trigonometric identities. Pythagoras' theorem. Basic arithmetic and algebraic processes are used to solve these questions. Remember that the square root sign equals exponent of half. Solution 1. Let u equals 3 times x squared minus 2 times x. This implies that the square root of u plus 9 and the square root of u minus 4, all equal to 13. Square the equation AMD, expand the brackets. We have that the sum of u and 9 plus u minus 4 plus 2 times the square root of, in brackets, u plus 9 multiply by u minus 4, all equals to 13 squared, which equals to 169. Simplify and combine like terms. It follows that 2 times the square root of the product of u plus 9 and u minus 4, which equals 2 times, in bracket, 82 minus u. Divide the equation by 2. It implies that the square root of the product of u plus 9 and u minus 4 equals 82 minus u. Square the equation. It signifies that the product of u plus 9 and u minus 4 equals square of 82 minus u. Expand the brackets. That is, the sum of square u and 5 times u minus 36 equals 6724 minus 164 times u plus square u. Combine like terms and simplify. We have that 169 times u minus 6760 equals 0. It implies that 169 times u equals 6760. Divide the equation by 169. Hence, u equals 6760 divided by 169, which equals to 40. But 3 times square x minus 2 times x equals u. This implies that 3 times square x minus 2 times x equals 40. We have that 3 times square x minus 2 times x minus 40 equals 0. That is, x equals negative b plus or minus the square root of square b minus 4 times the product of a and c, all divided by 2 times a, where a equals 3, b equals negative 2 and c equals negative 40. Substitute it into the formula. We have that x equals 24 divided by 6 or negative 20 divided by 6. After substitution and simplification of values. Hence, further simplification. We have that x equals 4 or negative 10 divided by 3. Solution 2. Since the figure is an isosceles right triangle, its base angles each equals to 45 degrees. Let u be side length. By Pythagoras' theorem, the square of the sum of 8 and 6 equals the sum of square u and square u, which equals to 2 times square u. Take the square root of the equation. It implies that 14 equals u times square root of 2. Solve for u. We have that u equals 7 times square root of 2, as shown on the screen. Label the 3 triangles as x, y, and z. From triangle X with base length labeled Q. Using trigonometric identity. Q divided by 8 equals cosine theta. Q divided by 7 times square root of 2 equals cosine 45 degrees minus theta, which equals the sum of cosine theta and sine theta, all divided by square root of 2. Substitute equation 1 for Q equals 8 times cosine theta. We have that 8 times cosine theta divided by 7 times square root of 2 equals the sum of cosine theta and sine theta, all divided by square root of 2. Simplify, that is, 8 times cosine theta divided by 7 equals the sum of cosine theta and sine theta. Combine like terms. This implies that 8 times cosine theta, all divided by 7 minus cosine theta equals cosine theta divided by 7, which equals sine theta. Divide the equation by cosine theta. Cosine theta divided by 7 times cosine theta equals sine theta divided by cosine theta. This implies that sine theta divided by cosine theta equals 1 divided by 7. By trigonometric identity, sine theta divided by cosine theta equals tan theta. Therefore, tan theta equals 1 divided by 7. Solution 3. Using law of indices. We write the left-hand side of the equation as sine 2 to the exponent of x equals 2 times square root of 3. We call it equation 1. Simplifying, we have that sine 2 to the exponent of x divided by 2 to the exponent of 2 equals 2 to the exponent of x divided by 4. Substitute into equation 1. This implies that sine 4 times u divided by sine u times cosine u equals 2 times square root of 3. Using trigonometric identity, we have that sine 4 times u divided by sine u times cosine u equals 4 times sine u multiplied by cosine u times cosine 2u, all divided by product of sine u and cosine u, equals 2 times square root of 3. This implies that 4 times cosine 2 times u equals 2 times square root of 3. Simplify and we have that cosine 2 times u equals 2 times square root of 3, all divided by 4, which equals square root of 3 divided by 2. Take the cosine inverse of the equation. It follows that 2 times u equals cosine inverse of square root of 3 divided by 2, which equals 30 degrees. Divide the equation by 2. It follows that u equals half of 30 degrees, which equals 15 degrees or pi divided by 12. Recall that u equals 2 to the exponent of x, all divided by 4. It implies that 2 to the exponent of x, all divided by 4 equals pi divided by 12. Solve for 2 to the exponent of x. We have that 2 to the exponent of x equals pi divided by 3. Take the natural logarithm of the equation. It follows that ln 2 to the exponent of x equals ln pi divided by 3. Applying laws of logarithm, we have that x times ln 2 equals ln pi divided by 3. Divide the equation by ln 2. Therefore, x equals ln pi divided by 3. All divided by ln 2. Solution 4. Label angle θ. Since the sum of θ and x equals 360 degrees. This is because sum of angles at a point equals 360 degrees. It implies that θ equals 360 degrees minus x. Hence, the sum of 50 degrees, 30 degrees, 20 degrees, and θ equals 360 degrees. The reason is that the sum of angles in quadrilateral equals 360 degrees. Substitute equation 1. It implies that the sum of 50 degrees, 30 degrees, 20 degrees, 360 degrees minus x equals 360 degrees. Hence, sum the angles. We have that 100 degrees plus 360 degrees plus x equals 360 degrees. (360 degrees cancel out from the equation. We have that 100 degrees minus x equals 0. Solve for x. Therefore, x equals 100 degrees.